Alright, so we've looked at finding limits using graphs and tables, and I want to take a look at a more analytical method. So what we want to do is establish some rules for limits. So the first one, if I've got the limit so the first one, if I've got the limit of a constant like b, so this would be something like the limit as x approaches c of 4. Well, there's no x in there to change. This is a not changing function. So this limit would just be 4. So this, our rule, is that if I've got the limit as x approaches c of some constant b, the answer is just going to be b. This one's slightly different. I've got the limit now as x approaches c of x. Well, x is now changing to whatever c is. And so as x becomes c, the limit is going to be c. Another kind of simple example. And then we've got this last one here is a function of x. So the limit as x approaches c of a function of x. Well, what we're going to find out is you can just replace the x with the c the same way that you did here. So what this is saying is that if I've got the limit as x approaches 2 of 3x, well, I can just replace the x with a 2. And this limit would be 6. So these are 3 basic rules, and probably the 3 most simple limits that we could possibly be working with. But let's take a look at a couple of problems where we're doing that. Here I've got the limit as x approaches 3 of radical x plus 1. Well, I've got x approaching 3, so I just replace x with 3. Pretty straightforward. And then of course you simplify. So the limit as x approaches 3 of radical x plus 1 is 2. Very similar down here. I've got the limit as x approaches 1 of this function. Well, if I rewrote this the same as I did there, we use one color for the original function and then another color for the limit value, what x is approaching. Well, if x is approaching 1, that means I just put 1s in there for the x's. And so now this is going to be 1 cubed, this is 1, so this is 3. 1 squared is 1, so I get a 2 there. And plus 4, and our answer is 5. So the limit as x approaches 1 of 3x cubed minus 2x squared plus 4 is 5. Now, let's take it up a notch. When direct substitution fails. Bum, bum, bum. Here I've got a little problem. If I try to use my same approach, and I say x is approaching 1, so I'll replace that with a 1, I now am going to have a function over 0, right? So everything is undefined. So when I'm presented with this, what I actually want to try doing is rewriting the limit in its factored form. So this is generally the first thing you try if you find out that direct substitution is not going to work. I would rewrite this as x plus 1 times x minus 1 all over x minus 1. And then I can cancel. And so now I'm looking at the limit as x approaches 1 of x plus 1, which I can write as a direct substitution, right? So now if I plug in that 1, my answer is 2, nothing undefined. Let's try to get down here. Same idea. If I plug in a negative 3, I'm going to get a 0 on the bottom. So I've got to come up with a different plan. I'm going to rewrite this as the limit as x approaches -3 of x plus 3 times x minus 2 all over x plus 3. These cancel out. Then I can take my -3 here, plug it in for my x value there. And the value of the limit is -5. One other trick to look at. Sometimes you try direct substitution, it doesn't work. You try factoring, it doesn't work. If you've got something like this, one more thing you can throw out there is rationalizing the numerator. Now, we rationalized denominators before in other classes, but now we're going to try rationalizing the numerator. It's the same idea. You just multiply the numerator by the conjugate. So I've got radical x plus 5 plus radical 5 would be my conjugate here. And then whatever I do to the top, I need to do to the bottom as well to keep it equal. So of course, like I'm just multiplying by 1, right, which is not changing the value of my expression here. So I'm going to FOIL this. So first I'll multiply radical x plus 5 by radical x plus 5, and that's going to give me x plus 5. And then if you notice, if I multiply these two together, I'm going to get negative radical 5 times radical x plus 5, and these two together, I'm going to get positive radical 5 times x plus 5. Those just wipe each other out. And then the last piece we have left, I've got this times this, which is going to give me a -5 down here. And then the denominator, I'm not even going to multiply it out. One little hint I'll offer you, don't be in too much of a rush to FOIL or distribute or do anything to this bottom part, because you'll find out quite often that we get some canceling going on here. Since 5 minus 5 is just 0, I can rewrite this as just an x on top over x times radical x plus 5 plus radical 5. And now these x's will cancel out. And I'm going to go ahead and rewrite my limit at this point. So now I'm looking at the limit as x approaches 0 of 1 over radical x plus 5 plus radical 5. And if you notice what happens, now I'm approaching 0 here, so I can plug that into my limit. It doesn't make anything undefined, right? This is going to become 1 over radical 5 plus radical 5 in the denominator there, which would be 1 over 2 radical 5. So a little bit more complicated, but not terrible. You guys can do it. I have confidence.